Hello, this is Grant Winker with Carlson Software Mining Division, and we're going to go through a short, about 1 hour webinar on taking a Quarry data set from start to finish. If you have any questions throughout the webinar, you can type in down at the questions window. I have someone standing by who will text back to you. And I'm going to go fairly fast. I have about 100 different commands to go through, so this will be recorded and put on our website that you can download and watch at a later time too. What we're beginning with is just a piece of topography and an Excel spreadsheet full of drill holes. I saved it as a CSV file, comma separated values, and it contains about 14 or 15 different drill holes. It has limestone sampled every 5 or 10 feet, and it has calcium, magnesium density. So we'll start with importing the drill holes. Now I'm going to be working in mostly the civil module, the Carlson geology module, and the surface mining module. So we begin in the geology module. This webinar will be used mostly as a training type webinar, but also could be used for just demonstration to show you new things that you might not know the program would do. So if you want to watch it again, like I said, I'm going to be going fast. You can replay it from our website. We'll start by defining the drill hole. I have an existing one. Let's open that. The define drill hole command is where you control the type of drill holes you're bringing in, the symbol size, the different types of drill hole symbols for the different types. And I believe these are going to be all core holes. I have a density down here in pounds per cubic foot, or it could be kilograms per cubic meter. And we'll save that file. It's just a little configuration file needed before you can bring in the drill holes. Next step will be import, export drill holes. We'll go right into drill hole import. Now I have a lot of these files loaded already, so we'll just go ahead and load them up. Use separate files. I'll say no. I'm going with the custom format, by the way. I'll say no, they're all in one file, the CSV file, and there it is. Open. And then the concept of this window is you match the used window on the right side with the column header from left to right. So if I were to start with a blank window over here, for example, I would have to match the drill hole name, the northing, the easting, surface elevation. You can just highlight them and add them over, or double click. And I should have one loaded already, or saved actually, so I'll load it up, called import format. And it goes all the way down to drill hole type, which is the last one. I don't have any description in the file. It's going to be a comma delimited file. I'll skip the first header line, and we'll hit OK. It said imported 14 drill holes. First thing I usually do after I bring them in is just double-click on a drill hole symbol to bring up the Edit Drill Hole screen. This gives you a check to see that they came in properly. You have the different thicknesses displayed. You can see the drill hole column on the right-hand side as you pick down. There's the drill hole name, surface elevation, and then all of the attributes, the chemistry, shows up here. You have calcium, magnesium, density is showing as well. And you can scroll down through the drill hole in this window. So it looks like it came in properly. We're ready to move on to the next step. I'll just go ahead and cancel that edit drill hole. The next logical thing that people like to do would be to just post the drill hole text or the names of the drill holes in the drawing. And that's done under drill hole, draw drill hole text, and we'll use the drill hole text formatter. We'll select all the drill holes to label. It found 14. We'll process no beds. I just want the drill hole name, which is over there. If it wasn't there, you would just highlight drill hole, go grab drill hole name, and move it over to the right. I'll just put the prefix to state drill hole space, and I'll put the text below and center. That sounds good, in row position 1. So this allows you to format the text around the drill holes differently. Hit OK. Give it your text size and offset from the middle of the drill hole. That looks fine. And there they are now. Drill holes are labeled nicely for us to see on the map. We'll go ahead and save that drawing because we brought in the drill holes and have done the text. Now we'll do a define strata. It's another configuration file. It's under drill hole, define strata. And if we were to read drill holes or read a pre-calculated grid model, it'll populate this list with the different strata and beds. Go ahead and edit one that we have called limestone. And if you're just going to draw them as plain limestone hatch patterns, you can grab, say, this brecciated limestone pattern. Give it a density if it's unique by strata. We'll give it 155. It's going to be a key strata. So it's just a way to control your hatching, your layers, and other modeling configurations. We'll go ahead and save that. You could put a legend out there. Let's hit draw legend on this. I'll hit OK on the legend size and exit. So it's just a way to draw your legend of the different strata in the drawing. Now we're going to draw some geologic columns now that we have the hatch patterns defined. And it's probably best if we just line them up along a polyline. So I'll go ahead and draw a polyline snapping to the center of drill holes. We'll just sketch about 4 holes in line. And then we'll go back to drill hole, draw geologic column. And we'll do them on a 2D grid. We'll project them along the polyline. And we'll do 150 vertical scale, so it's going to be a 2x vertical exaggeration. And we'll just do some labels. We'll just do a solid fill and OK. Pick the polyline. Any drill hole within, say, 50 away from that polyline, and window the holes. We'll go ahead and label the calcium, and we'll line up those drill holes up above over here. So you can see the different sample intervals of the limestone going down. Just color-coded them randomly in this case. I didn't set that up. The calcium's labeled on the left-hand side. You can see it ranges wildly from all the way from 0 to 100 throughout these different holes. So you'll see that in the block modeling. And there's other options. We could do draw strata connections. We could do the hatch. And we'll layer them individually again. Pick the same column line. And we'll connect up the limestone this time. And then there's the overburden up on top. So just one way to represent the holes in 2D on section. Another option would be in 3D. Let's go and draw them in 3D. And we'll leave everything else the same. We'll go back to solid fill on the hatch so we can render them in 3D. And let's not exaggerate them. Let's just put them 100, 100. Pick all the holes. We'll clear out. We don't need to label anything in 3D. So now it's drawing them into the map. And then when it's done drawing, we'll rotate it up in the AutoCAD orbit and look at the holes in 3D this way. So we'll zoom in. You can see they're drawn with 3D faces, so it looks best if you do the AutoCAD hatch. You can zoom in and see there's solid cylinders of the drill holes. If they were angled holes, you'd see them at the proper azimuth and dip as well. Okay, back to plan view. And let's just undo and go back. We don't want the holes in 3D for the next step. Now there's a couple of quick reports I'll show you that you should always do before you go into the modeling, and that's under drill hole reports. First one I run is strata order and count, just to look for any mistake, typographical errors in the spreadsheet, or looks like there's 14 holes total, and they both contain overburden and limestone, so we're in good shape there. If you had, let's say, 1 or 2 holes that had a misspelled word, that would show up in this report, and you go fix that. The next report checks for your invalid strata. This looks for things that are out of order. We'll grab the same number of holes, and this is what you want to see as a blank report with no problems. If you had limestone on top of the overburden by mistake in a hole, that would show up here. So you want to make sure you run those 2 reports before you get into the next step for modeling, which is where we're going now. I do have a surface topography grid file made already, so let's show you that. Let's go under Surface 3D Viewer, and I'll go grab the surface topo. Here's one surface topo, 10 by 10. You can see it's the existing pit with this ramp and our drill holes are spread out over in this area. Color by elevation, you get to see it a little bit better, and you can exaggerate it here if it's pretty flat as it is here to get a little bit more relief. So what we'll do now is make a block model of the drill holes over here using the same grid as our reference. So we're going to go into the block model pull down now and run make block model. Select the drill holes. We'll grab the limestone, and the attribute this time we'll just go with calcium only. You could grab multiple attributes here and put them both in your block model, but for today we'll just use calcium. That's what we're interested in. And we'll copy from a file for the XY position. And let's go grab the, actually these are all the same, so I'll just go ahead and grab one of these existing grids. And there's two main options for making a block model. You can have fixed elevations where your blocks are all flat at various elevations, or we can have it follow an ore model. If it's more stratigraphic, like this limestone is, we'll have the roof and floor of our block model follow the roof and floor of the seam. And we'll tell it to divide it up equally into 10 divisions. We'll go inverse distance, and our vertical weight factor, let's switch this to 10. So if it's a more stratigraphic deposit like this is, a higher vertical weight factor looks better. Then you can play with that. 1 would be more for metals type mining, where there is no stratigraphic relation. Go ahead and hit OK. We'll make this block model webinar. And we'll go second power on inverse distance, and it's not elliptical. So it wrote the block model. Next thing would be defining your different grades. And we'll go back to block model and define our grade parameters. Go ahead and make a new one. Just call it webinar. And you just start going through and adding your different grades. Here you call, for example, top grade. Give it a color. You give it a parameter, which would be calcium, is greater than 95, for example. Hit OK. So you just go through and spend the time to enter in all your different grades and intervals you want this broken down into. I'll go ahead and load up an existing one I have called limestone calcium. And there you can see I have 10 grades defined. Looks like every 10 interval of calcium. And there you can see all the different colors for the various grades. We'll go ahead and draw a legend here. So we can put this legend right over next to the other one. Get the same location, size maybe 250 to match the other one, and that's it. So there's my grade 1 through grade 10. So now we have the block model built. We have the grade parameter file built. We should be ready for some graphic viewing of the block model. All right, we've got this polyline drawn over here. Let's use that as our inclusion. I'll go up to block model, and let's run block model 3D viewer. We'll grab the, I guess it doesn't matter. This is the one I just made. This is the one I had already. It should be identical. Grab the limestone calcium grade parameter file. You can turn things on or off to view them. We'll hit OK. And we'll pick just this inclusion boundary. So now it's loading the blocks into the 3D viewer window. And these are 25 by 25 in the X and Y. And they're variable in height, since I told it to follow the ore model, but it's probably around 5 foot on average tall on the block height. So I'll turn off the color by elevation. There's no need to color the blocks. And let's exaggerate this a little bit, say a 3x vertical. And then if I take the arrow, the pointing device, you can point to the various blocks and see the grades show up in text down below. There I'm pointing at a grade 2 block. Over here at the yellow, it's a grade 5. There's a grade 6. This light blue should be, to rotate around, that should be one of the higher grade numbers. And it's a grade 9. Now, another advanced option is allowing you to turn off various blocks. Let's say we're interested in the lower grades. I'm going to go in here and click just like AutoCAD layers, various grades, and you can turn them off to see what's inside your block model. That leaves us now with, looks like we'll do one more. So that should be grade 1, 2, and 3. Go back to the rotate, zoom out, and you can spin it around to see what is inside your block model based on the various blocks. You can look at it from underneath as well. So this is the block model viewer. It's bringing in the block model. Just graphically, there's nothing on screen. There is another option where you can draw the blocks. Let's do this. I'll draw the blocks just a smaller area because I'm going to bring drill holes in also. I'll draw the block model inside. I'll go to Draw Block Model. It puts them in AutoCAD as nodes or points, if you will. And you can have a top surface and bottom surface limit. So if you want to draw the blocks on just a certain bench of this quarry, you can contain those elevation-wise. We'll do the whole thing. Draw inside this inclusion boundary. So there you can see the blocks. They're very small and hard to see, but they're there. And they're colored by the grade. And I'm going to go ahead and draw these drill holes in 3D one more time. I'll go back to Draw Geologic Column. And I'll do in 3D. I will do no label this time. And this time we're going to color by the grade parameter file also. So the drill holes now, instead of colored randomly by different intervals, we should now match our block model colored by the grade parameter, looking at the calcium file. And we'll just grab these 4 holes that are nearby the blocks I drew. So now I drew the holes into the screen, and we'll pull them into the 3D viewer window. It's just like the block model viewer. It's an alternate way to get there. And I grabbed some contours as well to show you the reference on the topo. And we can pull it down and zoom in and just kind of check out how the blocks and the drill holes should match up very well. And the black on top is your overburden. And you can see this drill hole has some grade 1, grade 2, grade 3, and it matches over here close in the block model. It's a few, several hundred feet, or maybe about 100 feet away from the blocks, so they're not going to be exact, but you can see the blocks do match the drill hole in that case. Over here, they look very good as well. So that's a nice way to visualize the limestone calcium in blocks and drill holes both. Next thing is adding that block model to a pre-calculated grid set. This will allow you to do cross-sections, slices through the block model, and also do reserve calculations to find out the tons. This is done under Strata Calc to find pre-calc grids. And I'll go ahead and load up the existing one we have. It's very small. It only contains about 5 different files. You can see them here. I have the surface topo grid up top. I have an overburden, which is the block model top grid. I have the limestone, which is the block model bottom. I have the block model itself. And then I also just threw in a calcium composite grid for calculation. So it's just 5 different lines of data. Go ahead and save that. And let's put in a polyline. Let's look at some cross sections. We'll go across the north side of the property, going from hole to hole and then into the open pit. Now we'll run fence diagram on Strata Calc. We're going to do a geological cross section. It'll be a 2D grid. I'll come off with pre-calculated grids, including the block model. And the exaggeration will be of 2x vertical. I have 100 horizontal and 50 vertical. I'll do hatch fence. I want to draw the geologic columns. And let's confirm their settings match. They should also be 150, and I want to color them also by the grade parameter file. And I want to hatch this fence diagram by the block model, so that is checked here. And OK. Grab the pre-calculated model and the grade parameters. Select your polyline and the section location. So there you can see a cross-section through the limestone from the top of the model to the bottom of the model, colored nicely by the calcium grade parameter file. Another new, fairly new option for us is multiple fence diagrams at once. So I'm just going to draw with my ortho on about 3 polylines through the area, and I'll tag them as fence polylines. tag fence polyline. I'll grab the top one. We'll call it fence 1. I'll hit enter. Grab the next one, fence 2, and this one, fence 3. Then back to fence diagram. And I'll turn on this new checkbox, process multiple name fence. And this time we'll turn on draw geologic columns. Make sure their settings are 2D, projected. 150. And turn on draw and fence diagram. And we'll do solid fill, color by grade parameter. So that looks good. We'll hit OK on the fence. And that's the spacing it'll put between each cross-section. Grab the model and the Carlson file. And then it wants the fence polylines, and you can just cross and select, and it'll grab the named ones. And zoom out and pick a spot, and it should stack them up one on top of each other. And it's looking for the Carlson file for each one. And then it drew the 3 cross-sections together with the drill holes on them. Any drill hole within, I think it was 50 feet I told it to draw, to include in the section. I didn't have any labeling turned on in the drill holes, but there you can see there's the drill hole on top of the block model. Okay, that's about it for fence diagram and cross-section analysis. Let's see how many tons we have inside this same inclusion boundary based on the various grades. We'll run a very quick and easy surface mine reserves command. We'll come pre-calculated for the top, and we'll go down to the bottom of the block model and on the strata. We'll come back and run this multiple times with different options turned on. At this point, it's not a named pit area, but I do want to get qualities. And I do want to break out the quantities, the tons, by the various chemistry of calcium. Hit OK. Pick the model and the grade parameter, and we'll grab this inclusion boundary. No exclusion. So I've calculated the surface mine reserves, and let's bring over all of the individual tonnage calculations. I'll highlight multiple with the control button and bring them over to the right-hand side. This is the report formatter. And we even have some no-grade tons showing up, but that's probably going to be 0. We'll stick these right below the key tons. And then we'll also bring over the average calcium in each of those individual grades. So for example, the grade 6 might be from 50 to 60 calcium, but this will give you the average within that 50 to 60 range. And we'll add those over to the bottom. We'll go ahead and save this format and display this. It tells you the grade parameters up top, what their ranges are. And since we just had the one inclusion boundary, here we have, looks like total by strata. Let's turn that off. Let's just go with the grand total. Display that. That looks better. We have overburden on top of limestone. So the grand total is about 13,830,000 tons. But the nice part of this report is it tells you the individual breakdown of the various grades. Like the majority of it is grade 4, about 4.1 million tons of grade 4. And the grade 4 calcium, which show up over here. Grade 4 calcium is bringing in right up about a 64.96. So that's the first surface mine reserves, just to get an overall estimate. About 13 million tons inside there. Okay, exit the report formatter. Now we're going to break this area up into smaller pits for some easier analysis. Let's go ahead and erase these polylines for now. And I'll draw a new direction line from the right straight over to the left to signify our direction of advance. We're going to switch into the surface mining module. Go to boundary, pit layout by advance. We'll pick this pit boundary and the direction line. We'll advance every 300 feet. We'll do, starting with pit 1, layer name will be pits 2. Give it a color. We'll do the intersection. And I don't need the original boundary. And we'll just call it the west area. And the prefix will be the word pit. So there it laid out new closed named pits for us. And we can check them out with identify pit. Just pick inside one. It tells you down below here. There it is, west pit 1. There's west pit 3. Now we need to give them a direction when we get into some scheduling. And that would be under pit directions, assign directions. We'll do it to the whole pit, not a specific bench. And for this method, let's have them all going to the north. So if I use this crossing polyline as my sequence, and I choose these pits in this direction, I want them coming from my left. So the LL would be my choice here. Hit enter. And then you should see a little arrowhead pointing through the pit in the direction that will be mine. If you refresh the screen, those arrows will disappear. Go ahead and save the drawing again. We've done some more addition to it. Now we'll do a little bit of 3D pit design. We have a command design bench pit for this, and we're going to mine these in order by pit name. And so we'll go to surface, design bench pit. Okay, we'll select our ground surface file, which is surface topo. And we'll pick our pit bottom. And let's have it match this approximate pit bottom elevation, which is around 1500 or 1495. So this 1495 elevation should be good. Make sure we grab the right one. No, I have it mislabeled. It says 20 by 20, but it's actually 25 by 25. You can tell in the preview window. It's nice that you can see a little bit of information about the grid file. And I'll write the surface history. I'll process all these pits by name. We'll put them on different layers. We're going to go up and out, and we'll use the offset method. And they'll be blue in different layers. Okay, I have two different groups defined, looks like. I'm going about 80 degrees every 50 feet of depth, and I've got a couple of 100-foot wide benches. But on the end walls, I have a couple of 5-foot wide benches. If you get a preview of this, you can see there's my end wall slopes. In a preview of group 1, I'm showing a couple of 100-foot wide benches, if I need them. It's pretty shallow here. I might just have the one bench. Go ahead and hit OK. Grid history to right, we'll just call that webinar. Select the pits to mine. And it's going to mine them in order by name. And then it wants group 2 slope group. So I pick on the ends. That's the end walls. And it's going to make an output grid. We'll just call it output. Yes, replace that. Then I want the next one, group 2. Enter. I'll make a mention here in the next release 2012, we have an automatic way to define these end walls with symbols instead of just picking like I did there. Here's a nice report showing you just total volume, cubic yards or cubic meters by bench. All right, exit there, and let's move these back to color by layer. I told it to go blue, but let's move them back to by layer so you can see a little bit better what's going on. And then if we do an AutoCAD orbit here, and we'll push it straight up to get a nice 3D view. And that, as I thought, we just needed the one bench to go over and then back up again to the topo. So we're pit floor, up one bench over 100, and then up again to the surface topography. And then over on the last pit, it just left this one bench. I could have changed that last pit so it didn't have a remaining bench, but we left it as is. Back to plan view. And then that design bench pit did make us a surface history file. Let's go ahead and view that as sort of a movie to simulate the mining advance. We'll go to View, 3D Surface History, and I called it Webinar. You can see all the different colors of the grids that will come by as we play it. We can make any changes. You could insert some backfill grids if you'd like at this point. We'll just go ahead and hit OK. And we'll look at it, tip it down on the 3D view. And let's probably exaggerate it up a little bit, maybe 3 times. And sometimes it looks better shaded when you run it. Sometimes it looks better if it's just the grid faces, or the grid's mesh showing up. So there's the surface history. And we'll go ahead and run surface mine reserves now on this little movie simulation you're watching. That'll tell you volume per pit per bench. Okay, exit there. And run surface mine reserves since the line work is needed. Surface history. Grab the model and the webinar and the Carlson file. So now it's going through and calculating 1, 2, 3, 4, 5 pits, 2 benches deep, with the high walls, angles, and the offset benches as well for volume calculation. First time we ran the overall volume calc on this large perimeter, it was just a vertical cookie cutter slice. Now it's actually using the surface history with the design bench pit template. This one here will turn off. We don't need the individual tonnage intervals. But surface history is still on. Okay, that was a little quicker. Now we'll total by pit. I want to move pit over to the top, move it up, and there's strata name, there's tons, yards, calcium, and we'll save that. And let's do a pit by pit total. I like to go to display for a preview, and then if it looks good, then you can go over to Excel, include totals, and export it out to Excel. So here's the same report. Here is pit 1. There's your tons, overburden yards, average composite calcium inside there. And we do have more tons than before based on our high wall angles and the bench that was on the final pit. So it's just an alternate method for surface reserves using the high wall slopes. And then the delay that I had to cancel out on, that was the third option I turned on to not only give you just basic tons, but also tons by grade, and that took too long, so I canceled it out. Next step will be some production timing. Now, let's go ahead and just quickly schedule these out with a couple of different methods. And I'll go ahead and freeze some things. These are all different layers, so it's going to take a second to freeze up this line work. Okay, so we're back to just the pit lines. Save that. And we're going to run now into surface production timing. It's a nice pre-scheduler to see, based on your input, it could be yards or tons that you're targeting, what your approximate life of mine is. We'll go with 155 density. We'll do 100% recovery. We'll just go down to the bottom of the block model. Or you could have a pit shell with 3D benches and go down to that. Select all your pits. And we'll select them all and mine them in order. Draw the blocks. We'll do the key tons of limestone. We'll set up a production timing table. And let's put in 500,000. So we're shooting for 500,000 key tons per year. And we'll just leave it blank, so it'll repeat that number all the way down, and the label will be blank. It'll just call it period 1, period 2, etc. Everything else looks good. We'll run. Let me go ahead and save this first, just in case. We'll call it 500,000. And run. So now it's ignoring the overburden, but it will report it, and it just broke these up into 500,000 ton blocks of limestone for us. And let's hit finish and check out the report. We have strata, but this time we don't have pits. We want to look at the period and move period to the top of your list. Save that, and I want a total by period, which is going to be, let's say, a year in this case. Display that. And there is the exact number, 500,000 key tons. Overburden on top of it, in this case, is 65,000 yards. At composite quality chemistry, is 60 on the Carlson. So our total by period. Okay, exit there. And that's the entire block model from top down, so it's much more than what we did before. But earlier we went down to just 1495 elevation. This was going down to the very bottom of limestone. And you can clear that out with a clear timing map or an undo, but we'll just run clear timing map to delete all benches, all pits. All right, now we're going to take it a step further and do some short-range planning. This is maybe a 4 or 5 year plan. Let's break it down into some smaller pits. What I'll do is freeze these, and I have other line work generated already in 2 layers for 2 benches. I have bench 1 and bench 2 blocks. Bench 1 is the red. You can see it covers a little larger area to allow for some high wall slope. And these are 50 by 100 size blocks, and they are offset. Here's your bench 2, which comes down from this pit floor and extends a little further out on that east side. So this is a nice, clever way to lay out your pits in different pit line work by bench. And these should have volumes already assigned just by surface mine reserves. And so we'll confirm that with boundary edit pit. We'll pick inside this. That is the bench 1. It has a little bit overburden and 1,574 tons. It also has calcium average and some elevation grids that we'll see used in our 3D pick window. If you pick inside a blue one, there it is as bench 2 only. And there is an overburden. It's just down in the limestone. So that one's much thicker, has 18,000 tons. And that's a different grid. Also, that's going down to 1495 elevation. Okay, so we have the line work laid out. This was just done with pit matrix layout. Under boundary, we used pit matrix layout for this, just like we did before when we made the first ones with pit layout by advance. The matrix allows a little bit more flexibility. We'll take this over to surface mine or surface equipment timing now, and we'll select all direction pit lines. I have some predefined equipment, just one loader, and it's moving, looks like 5,000. Let's drop that down. Let's go, well, that'll work. It'll move 10,000 tons per day, loader. And our calendar, we're pretty much blank for this, but the green dots are your shifts, and it's working every day, every shift in this case, but you can go in and take time off and take off your holidays, and we'll leave it all on for now. The next thing would be the attribute groups. I want to show you this. This is where we set up our group of grid files used for 3D pit. So it needs 3 grid files. It needs surface topography. It needs bottom of bench 1. This is the surface of bench 1. I'm at 1540 elevation with the grid I've made. And the bottom of bench 2 is at 1495. And of course, the block model itself goes much deeper. It goes down lower than 1400. So we're just going to cap this off at 1495. We'll go ahead and hit OK. We're going to start on June 1st, working 2 shifts a day. We'll put the reports in a separate database with this checkbox. The red is bench 1, the yellow is bench 2, and these are draped onto those actual grid files. You can see the surface. And this is that existing high wall coming down. These pits are right along this existing high wall. That's why they're coming down on this right-hand side. And the process of this window is to assign the blocks in order to the loader. And use that with the arrow, the pointing device. We have these bar charts in the middle to calculate real-time tons and yards and calcium. And so just to show you what's going to happen, if I double-click on this, it shows you the calcium in that little block is 78. It's 870 tons and 1,200 cubic yards of overburden. Pick the next one. There you can see the line work does not match up. That's why I laid out 2 different sets of blocks for each bench. They don't have to be the same polyline boundary. And so you just go on and you select which blocks to be mining in what order. watching your tons and yards down below real time. Okay, I'm at now 73,000 tons. Let's hit the calculate button and see how long that takes based on those loader productivities. So that took to June 13th. It took about 12, 13 days to get those 73,000 tons, and I'm looking at a 74 calcium. So we'll go ahead and exit that. And let's go to the other end of the quarry. Maybe we have some different quality down here. Let's say we need to do some blending. We can come down here and grab a couple more blocks. And my calcium is now dropping down to 69, 68. I'm at 139,000 tons. Let's increase that bar chart. So let's say we're going to shoot for 200,000 tons. And so this is max is 200,000. We're going to keep picking until we get to 200,000 tons. One more should do it. We went a little bit over. And we hit calculate to see what it is. Now it took us to July 4th, 2011. So it's a nice short-range planning tool to just start picking the blocks bench by bench to get your real-time tonnage and quality reported down below. If I exit here, there's a couple other options where I can bring in some surface features. I mentioned earlier that high wall existed, so let's go ahead and just grab those contours. And then they come into the 3D pick window just to give you a little bit more feel for where you're at in the mine. If you had some ramps or any kind of roads or center lines, you can still bring those in, anything with 3D, and then pick, just like before, to do in the sequence. Okay, so the process of this window is to do the picking, and everything I picked is in the middle window now, ready to go for scheduling. I just hit calculate. It finished on July 9th. We'll go to detailed reports. We'll do a, that's only about 1 month worth, so let's do first days of months. And okay, it's going to output some grid files based on, I need to grab the right grids here. This is the bottom of each bench. Bottom of bench 1 is 1540. No, wrong one, that's the bottom. That should be 1495. Bottom of bench 1 is 1540. And then it's going to prefix those in a new output grid format. So I'd only had 2 months worth, the red or the yellow and the green. Here's the report. We'll just take a peek at that. There's June and here's July. Exit there and exit there. So it did make us a 3D history. And let's take a look at that. Let's see if it output the surface history of the 2 months that we just worked. We called it, I think it was periods. There they are, the 2 grids. And then let's rotate that down and see. Okay, there's, I need to back up. I need to insert the original surface grid first. See, this is just the period 1, period 2. Let's add the original grid, surface topo, to the list. And move that up. So I start with original topo in red, and then let's change this color to green. And the 3rd month, or the 3rd grid, will be orange. And save that. We'll call it test. And okay. Now let's look at that in 3D. There's the pre-mine with the existing high wall. Hit run. There's the 1st month and the 2nd month. So it gives you a 3D grid file, a history of where the quarry is at the end of every month. Or if you're doing a long range, it'll give you a history of where the quarry is at the end of every year. It runs very fast, so you can see it does go through it and iterates 2 times. There's 1, 2. The 2nd month is very small. It just comes in here a little bit. Rewind one more time. 1, 2. That's a nice feature to output a history of the quarry based on every month or year or period that you're after. Okay, so I've got one more thing to show, and that'll be about time for wrapping up. I'm going to save this drawing as is, and I'm going to switch over to the 2012 version, which is coming out here very soon. And we'll do a quick design bench pit, and we'll extend that open pit down with a ramp at the same time. Over on the right-hand side, you can see this ramp coming down into the pit. And then let's take this closed polyline, and we'll shoot that down to another, let's go down another 100 feet or so. That's elevation 1400. And we'll start the ramp here, continue that ramp actually, and bring it around counterclockwise to there. That'll be under the surface mine module, surface, design bench pit. In this 2012 version has the option to turn a road on, so I'll create a road, making 100 feet wide. And I have a 5% slope there, but let's check and see what the slope of this road is. There's a tool under Civil. If you go to Profiles, Quick Profile, it's a good way to check the slope of an existing road or ramp. And we'll just do off the screen. Pick 2 points. There's the existing ramp, and you can see right here it's about a 4.8%. Looks like an average of 5% slope. So we'll continue that same slope in this ramp that we extend down. Okay, back to surface mining, design bench pit. Counterclockwise, I have my break line set to every 10. We don't need a history file. We don't need a grid. We'll just go with graphic line work. We'll hit OK. In this one, we'll just have the one group defined, 80 degrees. Go down to an elevation of 1400, floor, with no benches. The preview should just be a constant slope all the way down. Hit OK. Pick the line. Pick starting point for road. Let's begin this ramp right here. Okay, looks like it went down to 1400. There's a volume, just an overall volume of material it cuts out. Exit. And then let's do a little bit of manual trimming. I'm going to freeze the line work for the road and ramp in the pit. And I'm just going to erase the existing contours inside with erase by closed polyline. Erase inside. And then bring those lines back. And let's do a triangulate and contour. We'll put a closed boundary to contain our triangulation file. And I'll just use the triangulate and contour command from Civil to write the file inside that rectangle. And we don't need contours. Okay, it's going to write the file as pit with ramp, yes. And we'll use this inclusion and grab everything. The original contour is trimmed out and the new pit ramp. Got some break lines crossing. Let's view the file first. Surface viewer, pit with ramp. It looks fairly clean. You can see the original ramp has more triangles. There's my new ramp coming down, color by elevation. And let's do one final thing before we close. I'll just draw a polyline, and we'll drive down this ramp to simulate how the operators would go down in their haul truck. Come down to the pit floor and turn around. I need to drape that onto the surface, so I go to Civil module, surface, under 3D data, 2D to 3D by surface model. Pick the tin or the grid or the contours. Pick the line. Keep existing, no. And so now it's a 3D polyline, and I go to drive and simulate it with 3D views, surface 3D flyover. We'll come down that tin. We'll follow a 3D polyline. Pick the line and the tin. Okay, so here we are, and you can see it's a representation of this existing pit. There's my ramp coming down. A little bit of a bump over there in the corner. Let's see what it looks like. We're going at 40 miles an hour. Let's back up from the truck a little bit. This is the existing ramp coming down. And the original original pit floor was right here, so we extended the ramp and went down to elevation 1400 down here. Looks like there'll be a little bit of a drop off here, but after that it should be a constant 5% ramp going down. And that's about it. That finishes the quarry design I had planned for today's webinar. And just let us know if you have any questions, or if you want to watch this again. I know I went through it very fast. This should be recorded and saved on our website that you can watch and pause and follow along if you'd like. So with that, I will shut down, and thank you for watching.